This lecture discusses eclipses. In this section, we will look at eclipses and understand what eclipses look like. We will investigate solar and lunar eclipses. You will also understand the terms umbra, penumbra, and antumbra. The umbra is the dark inner portion of the shadow cone. Imagine a light source and an object casting a shadow. If you are standing within the umbra, you will not be able to see any part of the light source as the object blocks all direct light rays. The penumbra is the lighter outer portion of the shadow. The antumbra is the lighter part of the shadow that begins where the umbra ends. The images show what the eclipse sun would look like at the three locations. In the umbra, the sun is totally obscured. In the penumbra and the antumbra, you still see parts of the sun. There are four types of solar eclipses. A total solar eclipse can only occur if you are at the exact spot within the moon's umbra, which isn't very big. A partial solar eclipse is visible if you are in the penumbra of the shadow. Only some of the sun will be blocked. An annular eclipse occurs when the moon is farthest from the Earth in its orbit. This makes the moon look small compared to the sun. So during the eclipse, you see an outer ring of light from the sun. A hybrid eclipse is an eclipse that, depending upon where you are, can be annular or total. The diagram shows the geometry of a total solar eclipse. The moon shadow covers only a part of the Earth, a very narrow strip only about 100 miles wide. Total solar eclipses can only occur during a new moon. Views of solar eclipses can be quite spectacular. This diamond ring effect occurs during a solar eclipse at a point when the moon almost completely covers the body of the sun. There is just a little bit poking out. The irregular landscape of the moon means that the edge isn't perfectly smooth as it passes in front of the sun. It looks as if there are beads of bright sunlight coming through the valleys and between mountains. They are called Baily's beads in honor of British astronomer Francis Baily, who first explained them. Shadow bands are thin, wavy lines of alternating light and dark that can be seen moving and undulating in parallel on plain-colored surfaces immediately before and after a total solar eclipse. They are caused by the solar crescent thinning to a narrow slit, which increasingly collimates the light reaching Earth in the moments just before and after totality. The shadow's detailed structure is due to random patterns of fine air turbulence that refract the collimated sunlight arriving from the narrow eclipse crescent. During a total solar eclipse, the moon completely covers the sun's disk and the faint solar corona can be photographed. This halo of hot gas extends for millions of kilometers into space. This image was taken in southwestern Mongolia during the August 1st, 2008 total solar eclipse. The most recent solar eclipse occurred 21 August 2017, the Great American Eclipse. Sometimes eclipses occur when the moon is too far from the Earth to cover the sun completely. When this occurs, the moon appears in the center and a thin ring or annulus of light surrounds it. These are called annular eclipses. This composite of 5 exposures taken at sunrise in Costa Rica shows the progress of an annular eclipse of the sun that occurred on December 24, 1974. Note that at mid-eclipse, the edge of the sun is visible around the moon. A partial solar eclipse is visible if you are only in the penumbra of the shadow. Only some of the moon will be shadowed. A hybrid eclipse is a type of solar eclipse that looks like an annular solar eclipse or a total solar eclipse, depending upon the observer's location along the central eclipse path. During a hybrid solar eclipse, the Earth's curvature brings some sections of the eclipse path into the moon's umbra, the darkest part of its shadow that creates the total solar eclipse, while other areas remain outside the umbra's reach causing an annular eclipse. At time, the moon moves into the shadow cast by the Earth. A lunar eclipse occurs. We will talk more about causes of eclipses later. There are three types of lunar eclipse. A penumbral lunar eclipse is when the moon passes only through the penumbra, or partial shadow. They are barely visible. A partial lunar eclipse occurs when the moon does not fully move into the umbra. A total lunar eclipse is when the moon passes completely into the umbra or total shadow of the Earth. The diagrams show the circumstances of a total lunar eclipse, when the Earth's shadow covers the moon. A total lunar eclipse can only occur at full moon. Here is a penumbral lunar eclipse from March 2006. Very little of the moon is obscured. This partial lunar eclipse shows part of the moon still in sunlight. When the moon passes completely into the umbra of the Earth, the moon appears red. During a total lunar eclipse, the Earth lies directly between the sun and the moon, causing the Earth to cast its shadow on the moon. If Earth didn't have an atmosphere, then when the moon was entirely within Earth's shadow, the moon would appear black, perhaps even invisible. Earth's atmosphere extends about 100 miles, 160 kilometers above Earth's surface. During a total lunar eclipse, when the moon is in the Earth's shadow, there is a circular ring around the Earth, the ring of our atmosphere, through which the sun's rays pass. When the light passes through the atmosphere, red light is bent more, just as during sunset, and the red light from the sun reaches the moon, causing a reddish color. Depending upon the conditions of our atmosphere at the time of the eclipse, dust, humidity, temperature, and so on can all make a difference. The surviving light will illuminate the moon with a color that ranges from copper-colored to deep red. In December 1992, not long after the eruption of Mount Pinatubo in the Philippines, there was so much dust in the Earth's atmosphere that the totally eclipsed moon could barely be visible. There are 5 eclipses of 2018. Only the January 31st total lunar eclipse is partially visible from New Hampshire. See the link from Sky and Telescope for more information. This map shows the eclipse paths for the 14 total solar and 13 annular eclipses that occurred between 2001 and 2020. In each eclipse, the moon's shadow travels generally eastward along the eclipse path. Can you find any hybrid eclipses? The next total lunar eclipse is January 31st. Unlike total solar eclipses, which are seen in narrow strips, total lunar eclipses can be seen over large areas of the Earth. The January 31st eclipse is partially visible from New Hampshire. The next total solar eclipse is July 2019, visible in the South Pacific and Argentina. The next total solar eclipse is December 2020, visible in the South Pacific and Argentina. Again. The next total solar eclipse visible in the US is April 2024. It passes over northern New Hampshire. The plane of the ecliptic, or simply ecliptic, is a plane formed by the orbit of the Earth about the Sun. From the Earth, the Sun is always on the ecliptic. Solar and lunar eclipses don't happen every month because the moon's orbit is tilted with respect to the plane of the ecliptic. So during most months, the moon is above or below the ecliptic. Eclipses occur only when the moon crosses the plane of the ecliptic during a new or full moon. When the Earth, Sun, and Moon are in a line, we get the great Scrabble word syzygy, and either a solar or lunar eclipse occurs. In summary, a solar eclipse occurs when the moon passes in front of the sun's light and casts its shadow on Earth. A total eclipse happens about every year and a half somewhere on Earth. During a lunar eclipse, the moon passes into Earth's shadow. The moon can look reddish because Earth's atmosphere absorbs the other colors while it bends some sunlight towards the moon.